The Indian monsoon looks simple. Huge rain clouds arrive from the ocean and drop water across the land. It feels entirely automatic. But there is a surprising catch. This rainfall depends on something happening 15,000 kilometers away, here near South America. What? How is this possible? In 2015, farmers in the Marathwada region of Maharashtra planted their crops expecting normal rainfall. But the rains never arrived as expected. The monsoon was so weak that rainfall fell to just 40% of its usual level. The harvests were completely destroyed. Arahar dal, an important source of protein for millions of Indians, jumped from 85 rupees a kilo to 200 rupees a kilo. And you know what the reason was? The reason was this water, which by the way is 15,000 kilometers away from here, this got warmer by just 2 degrees Celsius. How? Today, over 46% of our entire population are farmers. Consumer inflation is dictated entirely by food prices. In India, the monsoon is the real finance minister. So in this video, we are breaking down exactly how this complex system works, how India is using artificial intelligence to predict accurate weather for individual villages, how we are using revolutionary financial tools to literally trade our weather on the exchange to protect our farmers. Let's go. Look at this. This is our Earth. But in space, Earth is not like this. It is tilted by 23.5 degrees. And this slight tilt changes everything. When Earth revolves around the Sun with this slight tilt, we get so many different seasons. In June, when the Earth is here, the upper half of the Earth is closer to the Sun, so it experiences summers. And the lower half, or the southern hemisphere, which is away from the Sun, experiences winters. Now as the Earth revolves, here at this place, both halves receive equal amount of sunlight, so you get spring in the upper half and autumn in the lower half. In December, the southern half gets tilted towards the Sun, therefore it experiences summers. The northern hemisphere or the upper half is tilted away from the Sun now, hence it's winters here. This tilt of 23.5 degrees is the reason why we have the Indian monsoons in the first place. Now let's come back to June. If the Earth were not tilted, each half of the Earth would receive equal amount of sunlight. The hottest place in this case would be this equator line. But because the Earth is tilted, the line of maximum heat would shift up by 23.5 degrees. Now, if you zoom in on the map of India, you will see this line passing through the states of Gujarat, Madhya Pradesh, West Bengal and Mizoram. But here is where the real twist happens. Land always heats up much faster than the oceans. Here are two identical frying pans on stove. One is empty and the other one is filled with water. Within just 1 minute, the empty pan is so hot to touch that I almost burned my fingers, but the pan filled with water, it's barely lukewarm. Solid materials like metal, rock and soil, they have a low heat capacity. They don't need much energy to raise their temperature. But oceans, they have a very high specific heat capacity. It requires a massive amount of energy just to raise its temperature by a single degree. Now let's look back at our hot zone over India. Because India is a massive landmass, it heats up relatively fast. But more importantly, look right above it. This region is called the Tibetan Plateau. This area is absolutely huge. It's around 2.5 million square kilometers, which is big enough to fit 7 Rajasthan states inside it. And then this entire region is lifted 5 kilometers above the sea level. This results in receiving much harsher sun rays. Now as this entire Tibetan Plateau region heats up, it acts like an atmospheric furnace, causing our hottest line that we saw to shift up. Something like this. Now basic physics tells us if the air becomes hot, it rises. As this hot air rises off India and Tibet, it creates a massive empty low pressure vacuum. At the same time, oceans, which are much cooler, they develop high pressure regions. This is why winds from the oceans rush in to fill this vacuum, converging right here. This global meeting point of winds is called the Intertropical Convergence Zone or the ITCZ. These winds, which start from the high pressure regions of the Indian Ocean, they pick up moisture from the oceans and enter India through both the Arabian Sea and the Bay of Bengal, bringing monsoons to India. Seems easy enough, right? But if this is how monsoon works every year, then why do we face floods and droughts in India? Take a look at the Marathwada region in Maharashtra. It is one of India's biggest agricultural hubs. In fact, this single region produces nearly 1/3 of India's tur dal, also known as arhar dal. It is the absolute backbone of daily protein for millions of Indian vegetarian families. But every monsoon, this region plays a gamble with its farmers' lives. When the monsoon winds rush in from the ocean as we saw, they meet the mountains of Western Ghats. These mountains force the clouds to go up, which cools them and then condenses the cloud into water droplets and cause a lot of rain on coastal cities like Mumbai and Goa. By the time these clouds actually reach the Marathwada region, they have just enough water to support this agricultural region. There is absolutely no scope for error. But then came 2015. Monsoon rainfall dropped to barely 40% of normal levels. The arhar dal crops were destroyed. As the supply collapsed, the prices exploded. The prices of this yellow lentil went from a normal of rupees 85 a kilo to rupees 200 per kilo. But do you know what exactly caused this? The entire India paid a high price for the basic food, for the basic necessities, and this is where it gets super interesting. This is because something happened 15,000 kilometers away from India, here near the city of Peru in South America. This event is called El Nino. You see, the Indian monsoon is not just controlled by these winds entering India as we saw, but there is a second major factor. Here near the South American coast, winds try to blow towards the equator. Why? Because the equator is hotter and therefore it forms a low pressure zone. But these winds, they cannot travel in a straight line because of something called as the Coriolis force. Because the earth is spinning, the ground literally slides from under the wind. Therefore, these winds deflect towards left and travels across the Pacific Ocean towards countries like Indonesia and Thailand. These winds are called trade winds and they do something incredible here. They also push the upper layer of ocean water with them. Remember, this upper layer of water is warm because it is constantly exposed to the sun. The deeper you go, the colder the water gets. So you end up with warm water near the Indonesia/Thailand region and cold water near the South American region. This warm water heats up the air above it. This air gets lighter, rises up, creating a second low pressure region here. This warm air goes to the top of the sky, splits into two completely different directions. Now, one half of this warm air travels across the Indian Ocean. By the time it reaches near Madagascar, it cools down, becomes heavy and just slams down at the Indian Ocean. Now remember, the southern Indian Ocean is already a cool high pressure zone. But when this massive upper atmosphere air current crashes down on top of it, it supercharges it, turning this region into an absolute high pressure monster. These moisture carrying monsoon winds now come towards India with a lot more increased intensity, causing a heavy rainfall in India. But sometimes these trade winds start flowing in the reverse direction. Now this trade winds pushes the warm water surface to the right towards South America, and this reverses everything that we just saw. This low pressure region turns into a high pressure region. The high pressure region that forms over the Indian Ocean now does not receive the boost it needs. The Indian monsoon winds now lose their strength. The Indian monsoon starts getting suffocated. This phenomena is called El Nino. El Nino suffocates Indian monsoon, but to be honest, it is still manageable. If the temperature of the surface of the ocean here is 0.5 degrees Celsius above the average, it is called a normal El Nino. But if it is 1.5 degrees Celsius above the average, it is called a strong El Nino. But if it is 2 degrees Celsius above the average, then the world enters a far more dangerous phase known as Super El Nino. In 2015, India experienced Super El Nino. India received 14% lower rainfall than normal, and the region like Marathwada, which is so sensitive to the rainfall, saw its crops like tur dal absolutely destroyed. Farmer lives were destroyed, the entire country paid the price. But this year, which is 2026, is again going to be a Super El Nino year. And not just any Super El Nino year, the temperature of the ocean this year is expected to be 3.25 degrees Celsius above the average. Look at this graph. We have seen 3 Super El Ninos till date. See, here's the thing. El Ninos are a rare event. The 2015 El Nino that we talked about was the worst one till date, with the ocean temperature being 2.5 degrees Celsius above the average. And do you know what scientists have predicted about 2026? 2026 is predicted to be an El Nino year with the temperature of 3.25 degrees Celsius above the average. The biggest El Nino year ever. Think about the gravity of that. An event happening thousands of kilometers away in the Pacific Ocean has the power to directly disrupt the Indian economy and impact your personal net worth. When local macro factors are so unpredictable, the smartest move you can now make is geographical diversification. By investing a portion of your wealth into the global markets, like for example the US stock market, you can effectively decouple your portfolio from the volatility of the Indian markets. You can do this easily and legally through Ind Money. By investing in US markets, you can buy shares of global tech giants such as Google, Nvidia, Microsoft and Tesla. Now, if you look at Nvidia, for example, in the last 10 years, it has given roughly 33,000% return. Also, S&P 500 of the US has given roughly 30% return in the last 1 year, while Nifty, the Indian index, has given 0% return. Now, all this is because the growing tech and AI companies are in the US and not in India. Also, since the investment actually happens in US dollar, you get what is called the dollar advantage. Look at this. The rupee has depreciated from 82 rupees a dollar to 95 rupees a dollar in just 2 years. This is 15% depreciation. But if you held US stocks here, you would have gained 15% just by the currency depreciation. Ind Money also has something called as fractional investing. For example, Tesla's share price is $400, which is around 38,000 rupees for one share. But what if you only have 5,000 rupees to invest? Ind Money allows fractional investing, which means you can buy a small part of the stock, and as the full share grows, your part also grows at the same rate. Ind Money also lets you start a monthly and weekly SIP in individual US stocks and ETFs from as low as 500 rupees. Also, if you look at global markets today, like South Korea and Taiwan, they are booming due to AI and semiconductors. And you know what's the best part is? Ind Money has zero account opening charges, and onboarding and KYC process, it takes just 5 minutes. So you can check out Ind Money by scanning this QR code or by checking the link in the description. Now let's come back to the video. In India, it is said that the monsoon is the real finance minister of India. The Reserve Bank of India, or RBI, measures inflation through a metric called CPI. Now, 46% of the CPI is made up of food and beverages. So when the monsoon fails, as it did in 2015 due to strong El Nino, food crops get absolutely destroyed, and hence the food starts becoming more expensive. Obviously, the inflation number, which depends on these food and beverages, starts to go up. Now, RBI is mandated to hold the inflation near a 4% level. So, to counter this inflation, RBI increases the interest rates. Now, this increases the rate of interest on loans taken by businesses. Therefore, businesses take less loans, they invest less. Ultimately, it leads to a lower growth of the economy. This same rainfall shock hits our exports. In 2015, total rice export earnings collapsed to just $5.85 billion. 25% below the 2013 peak of $7.85 billion. All of this leads to actual businesses earning lesser money, low returns on the stock market, lesser GDP growth. The opposite is also true. Strong monsoon years lead to great results for Indian domestic companies. Here is the thing, rural India is not just a farming region. Today, 46.1% of Indians are farmers. It is one of the biggest engines of economic demand in the entire country. When the monsoon is good, farmers earn more income from better crop production, and that money starts flowing through the entire economy. For example, in 2025, India had a good year, receiving 108% of its historical average rainfall. Wholesale tractor sales jumped by 28.2% and retail tractor sales rose by 30.1%. During the same period, even domestic two-wheeler wholesale sales grew by 7.2% year-on-year. Even India's biggest companies, they closely track monsoon performance because rural consumption drives a major share of their sales. In fact, rural households now contribute over 40% of the premium FMCG demand in several categories. A good monsoon doesn't just grow crops, it grows demand. But then every coin has two sides. Sometimes these trade winds flow even faster and more aggressively. Now they push even more warm water towards the region of Indonesia and Thailand. This extremely supercharges the Indian monsoon. more rainfall reaches India, rainfall often improves, groundwater gets refilled, agriculture receives a boost, Indian GDP receives a boost. This is the opposite of El Nino and this is called La Nina. But if it becomes too much, La Nina can also be dangerous too. Too much rainfall can basically trigger floods, damage crops, cause landslides, cause destruction across several parts in India. Excessive rainfall in Maharashtra in 2025 damaged nearly 6.8 lakh hectares of crops out of 14.4 lakh hectares sown. In other words, almost 1 out of every 2 hectares cultivated was affected by floods, waterlogging, highlighting how excess rainfall can also severely hurt farmers and agricultural output. But something is making this problem even worse. Earth's temperature is rising continuously. Because of the greenhouse gases like CO2 emissions, Earth's temperature has already risen by more than 1 degree Celsius in the last 50 years. Now, for every single degree Celsius the planet warms, the Earth's capacity to hold moisture shoots up by roughly 7%. What is the result? The result is unseasonal rains. In one of the region of Bikaner in Rajasthan, farmers reported 100% loss of wheat, mustard and chana crops. In fact, if you map El Nino and La Nina occurrences over the years, you will see that after 1960, the swings between El Nino and La Nina have become more extreme. Dry days are getting even more drier, while wet days are becoming more violent, causing floods and destruction. But there is one way to reduce the impact of monsoon on us. We need to predict the monsoon right. This is the monsoon rainfall that the Indian Meteorological Department, that is IMD, predicted. Now look at the actual rainfall. You will see a lot of deviation. If, for example, you predict low monsoon, the farmers can plant non-kharif crops like wheat, barley, mustard. Non-kharif crops are crops that need less water. But now, if your prediction gets wrong and turns out India will have good monsoons, your non-kharif crops gets destroyed. Also remember, accurate prediction isn't just about helping a farmer choose the right crop seeds to save his income. In the era of global warming, hyper-local prediction is a matter of saving lives. In June 2013, winds carrying water from the Bay of Bengal met with the Kedarnath mountain and caused a huge cloudburst. This cloudburst caused a huge flood in the Kedarnath valley.
Widespread and heavy rains led to flash floods in all the major river valleys of the state, wiping settlements and destroying lives.
Unfortunately, this was also in the middle of the Char Dham Yatra and 9 lakh people were inside the city. This claimed around 6,000 lives and is one of the worst natural disasters in India till date. What is mind-boggling is, IMD did issue warnings of heavy rainfall but failed to predict its intensity. So no one took it seriously. These heavy rainfall warnings were actually issued very frequently in the region, and since most of the times nothing happened, people didn't take it seriously. Similar disasters happened in 2023 in Himachal Pradesh, then in Wayanad in July 2024. These are not one-time disasters. They point towards our failure to predict local weather events. To solve this, Indian government launches Mission Monsoon in 2025. The goal is to upgrade weather prediction facilities and make India a weather-ready and a climate-smart nation. Today, we can forecast weather at a resolution of 12 km by 12 km. Under Mission Monsoon, we want to reduce this to 6 km cross 6 km, which by the way is also an average size of a village in India. So each village can get a local customized weather forecast. Indian Meteorological Department is also using AI-driven forecasting systems. Using 100 years of past rainfall data and combining it with local weather stations, IMD gives out a weather forecast every Wednesday up to 4 weeks in advance for 16 states and 3,000 sub-districts. From a simple Google search, I was able to get forecasts for many districts in Karnataka. Then they just went a step further. Using advanced AI techniques, they are able to lower the resolution even below from 6 km cross 6 km to just 1 km cross 1 km with forecasting up to 10 days in advance. This is extremely hyper-local forecast. Yes, currently it is in the pilot phase, launched only in the state of Uttar Pradesh, but if it works as designed, this is a game changer for the entire country. Finally, there is one more way Indian farmers can lower the financial damage which is caused by weak monsoons. Now, being from the finance background, this one is my favorite. The National Commodity and Derivatives Exchange, or NCDX, has launched India's first ever SEBI-approved exchange-traded weather derivative contract. The ticker symbol is RAIN Mumbai. It is designed by IIT Bombay using official data from the Indian Meteorological Department. It tracks cumulative deviation rainfall, basically how much Mumbai's actual monsoon rainfall is deviating from its long period average. So if the actual rainfall exceeds the historical long-term average, the index rises. If the monsoon fails, you have low rainfall compared to the historical average, the index drops. Anyone, including farmers, can use this to hedge against both a weak monsoon, which can destroy the harvest, or a very strong flood like monsoon, which can again destroy the harvest. That's all from my side. If you like the video, do hype the video, and don't forget, if you want to invest in the US markets, check out InMoney from the link in the description or by scanning this QR code. Do come back for more videos. Let's meet in the next one. Thanks.